Hi, my name is Vladimir Horikov, and this is the course about domain-driven design and working with legacy projects. In this module, we will explore other ways of dealing with legacy projects, such as turning them into microservices and building a domain event channel on top of them. In the preceding modules, we did an excellent job building the new functionality without touching much of the legacy code. The anti-corruption layer, especially the synchronizing anti-corruption layer, is a great tool that enabled us to do that. But there still are situations where it is not enough. The anti-corruption layer is a flexible but highly specialized piece of software. We made it synchronize our bubble-bounded context with the legacy system, but what if there are several bubbles like ours? Each of them would have their own domain models, otherwise they would be just one bounded context, and each of them would work with the legacy application in a similar yet different way. What would we do in this case? If we were to apply the same approach we used previously, we would need to implement a separate anti-corruption layer for each of the bubbles. We will not be able to reuse the same one, and that could result in a lot of repetitive work. This additional effort could easily become prohibitive. One option here could be to keep only one bubble and put all new functionality to it, and that would work in most cases. However, there are situations where having only one bubble just doesn't make sense. For example, if you are dealing with a large legacy application and need to work on different parts of it simultaneously, you would want to split this work among several developers or teams of developers to reduce the communication overhead and improve the speed. The approach with the anti-corruption layer could become an obstacle in such a situation. Are there any ways to overcome it? There are a couple. Let's review them in this last module of our course. One option to improve the situation and make the anti-corruption layer reusable is to expose the legacy application to other bounded contexts as a microservice. Here's how it could look. Because most legacy codebases are not designed to be used in scenarios with network communication, you would need to introduce an adapter on top of its codebase that would do that. This adapter will expose some JSON-based REST API that would work either with the legacy codebase or with its database directly, like in our sample application. The adapter would essentially act as an anti-corruption layer. Just as an anti-corruption layer, it would do the translation. The difference here is that this translation would be not between the legacy system and some particular bubble, but rather between the legacy system and the REST API. This would enable the reuse of the translation effort. Here we are abstracting away one of the recipients of the translation and allow any bubble to connect to the legacy assets using the same API endpoints. Note several important points here. First, you will need to introduce a separate set of data contracts that the client bubbles will use to communicate with the legacy microservice. You should not use the classes that already exist in the legacy application for that purpose. For example, if the legacy codebase has a class for delivery, like in our case, don't use it as is in order to serialize data into JSON. Convert it into a nice-looking data transfer objects and serialize that object instead. The resulting set of DTOs, data transfer objects, would become the data contracts between the legacy microservice and the external bubbles, or as Eric Evans called it, the published language. Now, when you use the API from the other end, from the bubble-bounded contexts, you shouldn't use those data contracts as is either. This published language is still external for the bubbles, and they need to convert it into their own domain models with their own ubiquitous languages. Remember, any information crossing a context boundary must be translated. Messages or data contracts are not somehow neutral. They are always expressed in a language based on some system of abstractions, and you shouldn't let them enter a bubble that uses a different language. In practice, that means you should always keep the bubble's domain model separate from the data contracts. Note that I'm using the terms message, data contract, and data transfer objects as synonyms here. In that sense, when you're working in a microservices environment, you always end up having an anti-corruption layer. That's because you always translate the incoming messages into the language of your domain model before reacting to them. This very act of translation protects your bounded context from the external influence, as you are able to keep its model isolated at all times. You can say that each microservice has a built-in anti-corruption layer inside. Another option is to build a domain event channel out of the anti-corruption layer. The main idea here is to take the synchronizing anti-corruption layer which we ended up with in the previous module, and instead of pushing updates from the legacy database to the bubble, make it push events on a message bus. This way it will announce all the changes happening in the legacy system, and all interested parties will be able to subscribe to those changes and act accordingly. The main difference between this approach and the microservice one is that the event channel provides a push model as opposed to pull one. With the microservice, you need to pull the legacy system yourself, whereas the event channel will push the changes to you automatically. This is useful when you build a bubble that doesn't really need much information from the legacy application and doesn't need to modify anything in it either. For example, if you need to log how many deliveries the legacy system ships or keep any other kind of statistics, the domain event channel would be a perfect fit for you. With it, you are able to encode any required information in the events themselves, so that the bubble won't ever need to reach out to the legacy application. The system will tell you what's going on with it in a series of events. Note that it only works if the bubble doesn't need to change anything in the legacy system. If it does, then you could still employ the event channel, but you will have to combine it with the microservice approach. You need to apply the same guidelines when you subscribe a bubble to this event channel. Events, just like regular JSON messages, are expressed in some language too, so you need to translate it into your own domain language when processing those events. Both these approaches scale really well, and you can even apply them together. In both cases, you're able to effectively reuse the anti-corruption layer when connecting external bubbles with the legacy application. Here are some useful links that I referred to in this course. The source code for this course is available on GitHub. It contains 3 folders with different versions of the codebase: initial anti-corruption layer and synchronizing anti-corruption layer. You can implement all the requirements yourself, or go ahead and look at the end result. If you need an introductory course on the topic of domain-driven design, I recommend my Domain-Driven Design in Practice one. This is the original paper on the topic of anti-corruption layer from Eric Evans. And this is the article about the differences between entities and value objects. We've made a great progress in this course. You have learned about the anti-corruption layer, what it is and why it is useful, and how to implement it in practice. To summarize, it is useful because it allows you to combine the benefits of a full rewrite and gradual refactoring, in a sense that it allows you to work on a greenfield domain model while still delivering business value. We implemented new feature requests in several steps. For the first change in the cost estimate calculation logic, we introduced a bubble with an anti-corruption layer in the form of repositories. It worked with the existing legacy database. For the next feature, we had to introduce our own data storage because the old one wasn't enough for us. We promoted the bubble into an autonomous bubble by cutting all connections to the legacy system and turned the anti-corruption layer into a synchronizing anti-corruption layer. This autonomy allowed us to scale the bubble separately from the legacy application. Finally, we discussed further ways of dealing with the legacy system, exposing it to the outside world as a microservice, and building a domain event channel on top of it. Both techniques help you reuse the anti-corruption layer among several bubbles and scale your software even further. Be sure to subscribe to my blog, where I will be putting announcements about more courses about domain-driven design. This is the short link for you to do that. Also, feel free to get in touch with me. Here are my email, Twitter handle, and blog. This is Vladimir Horikov. Thank you for listening.